Welcome back, dear students. Today I am back with a very tricky question, and this question is something like either you can solve it in 2 or 3 minutes, or you won't be able to solve it. So I want you to attempt it first, and if you can solve it within 2 or 3 minutes, then you are excellent. Otherwise, you just watch the video and learn the very important tricks which I am going to explain over here. So the question says there is a rod of mass m and length L which is suspended from a ceiling with the help of two light inextensible strings of length L so that the rod is horizontal. If the rod is given sudden angular velocity omega about its central vertical axis, find the increment in the tension in a string immediately after the rod is given angular velocity. Many of you might be thinking that the rod is going to rotate in a horizontal plane. This point will be coming something like this, and this will be going something like this. So overall, this rod will be rotating in a horizontal plane. So why will the tension increase? If any motion, if suppose there is any table and there is a rod kept on it, and the rod is given a horizontal, it's given an angular velocity on the table plane. So you might be thinking there is no vertical acceleration. So why will the tension be increasing? So what you are missing, let me cover it. So in order to just visualize the problem, let us imagine a situation in which there is a ceiling and there is a string of length L and a ball of mass m is hanging. What I do, I suddenly give it a velocity v in this direction. So what do you feel? Will the ball be accelerated or non-accelerated? This ball is going to move in a circular orbit, and we know any object moving in a circular orbit is always accelerated towards the center with acceleration v square upon r. So this ball is having a vertical acceleration of what magnitude? A is equal to v square upon L. So I hope this gives you the hint of this question. Same idea which we have learned here, we are going to use and see how easy this question becomes. Okay, now this is our assembly. Okay, now you see what is happening here. Here, this is the central vertical axis, and the rod has been given angular velocity like this. That means this end, let us say A, it is coming in this direction, and this end is going, let us call it end B. Okay, it is going in this direction. So if you see the top view, then what you see, this is the rod of length L, and it is rotating about, this is the center C, let us call, it is rotating like this with angular velocity omega. So what is the velocity of this point? Omega L by 2. This is the velocity. And what is the velocity of this point? Again, v is equal to omega L by 2. Simple, v is equal to r omega applied. So what will be the velocity of this one? Same logic here. Velocity will be omega L by 2 here and omega L by 2 here. Okay. Now this string, you see, this string is moving in a circle, vertical circle. That means this end will be having an acceleration of what magnitude? V square upon the length of this string. Okay, this will be the acceleration of point A upward, where v is what? Omega L by 2, isn't it? And same is the story with point B, symmetric. So this point B, it will also be moving upward with acceleration what? V square upon L, where v is this omega L by 2. Okay, so now you must have realized how easy this question is. You see, it is a rod, and this is point A, let us say this is point B. This point is having acceleration of what? V square upon L acceleration. Similarly, this point is having acceleration what? V square upon L. So, if both ends are moving with acceleration A and the rod is rigid, what you feel will acceleration of the center of mass? Obviously, it will be the same. ACM will also be A. If not, then the rod will break something like this. But we are not here to break the rod. So, acceleration of center of mass will also be equal to A. Okay. That means we can say that before the angular velocity, like this is the situation. Let us say, and this is the ceiling. Let us say before the angular velocity, tension was Ti in the both strings, and if you give force balance, its mass is mg. So before any angular velocity, the vertical equilibrium says 2Ti is equal to mg. Let us call this equation 1. After the angular velocity, what is happening? This point is the center of mass is moving with some acceleration A, which we have already calculated. A is what? V square upon L. Okay. So now you see what is happening. Now it is something like this. This is the string, this is the rod, and let us say after the angular velocity, tension is Tf. Okay. And force is obviously weight downward, and this rod center of mass acceleration is A. That means if you apply the equilibrium in vertical direction, what we can say? 2Tf minus mg is equal to what? Ma. And A is what? A is nothing but V square by L. That means 2Tf equal to mg plus mv square upon L. What is V? V we have already seen here. V was what? Omega L by 2, simply because of the angular velocity. Okay. So V we can write omega L by 2. Omega L by 2. So put it over here. What you get? 2Tf equal to mg plus m upon L times V square. That means omega square L square by 4. Now what you are supposed to find? You are supposed to find increment in tension. Increment in tension means what? Delta T you have to find. Delta T is what? T final minus T initial. So T initial is this one from 1 and T final from 2. So subtracting 1 from 2, you get Tf minus Ti is equal to what? Simply subtract it, you get m omega square L square upon 8 times L. This is the increment in the tension, delta T. So this is the answer we got. Okay. So like this, you see, it is a very simple question, but if you go in the mathematics or you catch the wrong direction, then it will take you in the trouble. So this is the question, and you can see how we are able to solve it so easily. Now be prepared. I am telling you one more thing. Next time be prepared for another similar question which may definitely come in JEE on a similar concept. I am giving you the question. Imagine a disk of mass m. Okay. Uniform disk of mass m, in which there is a point A here. Let us call it, this point is A, A, B and C. These 3 points, vertical strings are equal vertical strings of length L are, it is hanging from a ceiling and through these cords. And if you see the top view of the string, then A here, B here and C here, okay. They are on the periphery, though I am showing it a bit inside, but they are on the periphery and they form equilateral triangle. So I ask you, if this string, if this disk is given a certain angular velocity omega, what tension will develop? Its mass is m. Find the tension developed in strings just after the angular velocity. In a string just after the angular velocity is given. So you try this and find the answer just after the angular velocity is given. Okay, so it will be a very, take their length L, 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 L and take the radius of this disk as R. These points are exact at the periphery. In fact, the figure is not very much clear, but these points are lying in fact on the periphery. So, and ABC is an equilateral triangle. ABC is equilateral triangle. It will be a very good question and you can try and whatever answer you get, mention it in the comments and I will let you know whether you are correct or wrong. Same concept, same principle which we have discussed in the question, same will be applied here. So I thank you very much for watching this video, and in case you have any queries, any questions, any suggestions, any doubts, please feel free to comment. Thank you very much.